Our next molecule is going to be SO2. Draw that here. Sulfur has 6 electrons. Oxygen also has 6. There are 2 of them, so we're going to multiply that and get 12. That will give us 18 valence electrons. Right, for this model right here, we have a double bond right here and a single bond. There is going to be 4 electrons here to satisfy the octet rule. There is going to be 6 here. And then we have 2 lone pairs left over. We're going to determine our charges. So we have 6 minus 1, 2, 3, 4, 5, 6. It's going to give us the charge of 0. If we look up here for the sulfur, it also has 6, but we have 1, 2, 3, 4, 5. Oh, I'm 5. This is going to be a 1. So we're going to have a positive charge right here. And then this one right here, we're going to do 6 minus 1, 2, 3, 4, 5, 6, 7. And that is going to give us -1. So we're going to have a negative. My apologies, the video did cut off. But where we were at is we were drawing inarticulately or arrows. I'm so sorry I butcher saying that every single time. And then we add in our degrees. It's going to be 120 degrees. And we know that because our electron domain geometry is trivial. I'm so sorry, I have full iPhone storage, so it keeps cutting the video. I'm trying to fix it. But as we were saying, the electron domain geometry is trigonal planar. The molecular geometry, or the shape, is going to be bent. This molecule does have resonance. So then we're going to draw that there, that double arrows. And we're going to draw the other structure, which is actually going to be the exact opposite of this one. So draw that there. Again, it is important that the octet rule is satisfied. And then since it is the opposite, this is going to be the negative molecule, and this will still be the positive one. And then lastly, it can be seen in a very unstable form where it only has single bonds. However, this structure is relatively high to happen in nature. And I'm gonna add the double arrows on these ones. Same here. Then we have our lone pair up here. This has, it's gonna be 6 minus 1, 2, 3, 4, 5, 6, 7. And that's going to be the same for both of these. So we're going to get a -1 charge for both of the oxygens. And then for the sulfur, it is going to be 6 minus 1, 2, 3, 4. And you get 2. But again, this is a very unstable form of this molecule. For our representation of the structure, right here we have, the oranges represent the oxygen, and then the strawberry represents the sulfur, and the sixlets represent the lone pair on the sulfur atom. And we have our double bond right here and our single bond. This molecule is polar because it is asymmetrical, and the overall polarity of it It is, it's going down. And then the hybridization is SP2.